Hello everyone, I hope you all are doing well. Today's topic is principle of conservation. Let's see the statement of conservation. Total momentum before collision is equals to total momentum after collision. The word total is like net resultant. Now, what is this total momentum before collision is equals to total momentum after collision? If you see the word principle of conservation, conservation is something, it means something is constant. If you will recall the principle of conservation of energy, so we say the word energy can neither be created nor destroyed, it only transforms from one form to another form. So what does this conservation means? Wherever you are going to stick the word conservation, conservation of momentum, conservation of energy, it means the value is constant. The value is constant. So here the momentum is constant before the collision is equals to momentum after the collision. Suppose if I said there is a two cars, car A and car B. So before collision, the total momentum of car A plus car B is equals to total momentum of after collision of car A and car B. So let's try to understand in the form of symbols, because everything which we learn in the form of principle or in the form of definition, we always convert in the form of equations. So let's see the example. We have two cars, car A and car B. Initially, before collision, car A is moving with u1 velocity and car B is moving with u2 velocity. As you know that u symbol we are using for the initial, but you can take any symbol, okay, in the form of v, v dash, v1, v2, like that. Okay, the mass, the car A is mass m1 and car B mass is m2. Second situation is during the collision, means both the cars are collided. Sorry for this. Okay, now both the cars are colliding each other. Now after the collision, we know that definitely either the car is going to move away from each other, or maybe it will move towards each other. Maybe it will go in the same direction. So the third situation is after collision. And our statement is saying total momentum before collision, this part, is equals to total momentum after collision. Okay, so there is no in the equation, there is no use of during the collision, right? So let's use these two situations and let's see how to write the statement in the form of equation. So total momentum before collision, let's find out the total momentum before collision. Total momentum before collision. Before collision. What do you mean by the total? Total is what? It's a sum, right? So the momentum of A plus momentum of B car before collision. So before collision means we will see only this part, this part. Okay. So momentum before collision is, what is the basic formula of momentum? That is mass times velocity. The basic formula of momentum is mass times velocity. So here the mass of A body is m1 and the velocity before collision of A body is u1, plus the mass of B body is m2 and the initial velocity is u2. So this is the total momentum before collision of A and B body. Now let's come to the total momentum after collision. Total momentum after collision is equals to, again, the momentum of A and B. This is your A body and this is your B body. Okay, there's one thing interesting here. Is it the mass is going to change after collision because the velocities are changing, but is it the mass is going to change? No, the mass will remain same. Although in some situation you can say that if two bodies are colliding, so maybe the body is going to break and the mass will change, but we are not taking that situation. We are taking the situation when two bodies are colliding, then the velocities are changing but the mass will remain same. So I'm taking only again momentum of A body plus momentum of B body, but after collision, so after collision the mass will remain same but the velocities are now v1 and the mass m2 and velocities are v2. So in the form of equation, if you will write, then this statement is in the form of words and these are in the form of equation. So according to the statement, can we write m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Sorry, this m is looking like it's a capital M, but it's a, let's make a small m. Okay. Okay, so this is the equation in the form of symbols and this is the principle of conservation in the form of words. You will see so many questions are on the basis of this equations, right? In the next video, we will do some questions on momentum and on the principle of momentum. Thank you so much.